Welcome to the second in our SP3 series. So in the first video we took this Seriously Pro F3 flight controller and we went through the basics. We talked about why it was different from things like the NAS-A32 and other flight boards that run Clean Flight as the flight control software, and then we spent a bit of time doing things like updating the firmware, and then we installed a receiver. So this is how I've got mine configured right now, and in this video what we're going to do is now install this into a craft and take it for our first flight. But to get there, there's a couple of things that we obviously need to do. As you can see, we have no pins installed, so we're going to have to install the pins. We're going to have to install it into the craft and stick it in the middle of a 250 class quad is what we're going to use to install it into. And then we're also going to have to test things and set up the motors, and then finally take it for that flight. So before we actually get to the point where we do anything else, it's worthwhile taking a little bit of time and talking about the things that we have to consider before we mount this board onto a quadcopter. So here's the things that we need to think about. The first of all is RFI interference, radio frequency interference, and this can be either a radio frequency or magnetic interference that's coming up from the power system. If you're mounting the board on a craft that has a PCB power distribution board that's actually part of the lower plate, then I tend to find those are really bad for generating lots of noise and magnetic interference that affects the compass, and that compass is needed if you want to use any of the GPS functions. So having a compass that's deflected by the power that's running through the power lines right next to it is a very bad thing indeed. So think about where you're going to mount the board. Make sure it's physically separated from the power lines, the power distribution board, or the wires that you're running to and from the ESCs. That'll give you the best chance of not having any of those problems. The other thing you can do is install something like Mu Metal, MU Metal. You've seen it in some of my other videos. It's a great thing for shielding against electromagnetic interference, and I tend to put them under most of the boards these days, between the board and the power system in the craft, if I'm going to be using the compass for anything at all. Next thing we need to think about is we really want it as close to the centre of gravity as possible. A lot of the frames that we get these days already have the mounting holes built and drilled into them, so we know exactly where the flight controller should go. A friend of mine over in the States recently built his first quad and put the flight controller on the top of the craft where the Mobius would normally sit at the front of the 250 quad. Had amazing problems trying to get that to fly very well. I gave him the advice to move it down to the centre of gravity in the frame where it's supposed to be, and without changing the PIDs or anything, it flew brilliantly. So not placing the board in the right place does mean that it will feel the sensation of movement in a slightly different way, and that can cause problems. There is a barometer at the bottom of the board. If we just go back to the table, so here we are. If we look underneath the board, we can see the barometer here. It's this little tin can. The camera will catch up, there we go, with the two holes in it. That is actually sensing atmospheric pressure. The challenge with this is that as any breeze catches it and blows across the top of it, it will change the barometric pressure, and that will be read by the sensor. And if the board is using the barometric sensor to actually establish the height that it's flying at, then the change in pressure by a stray breeze coming across it will cause the board to react. Thing we need to do is get a little piece of closed foam. This is the foam that actually came in the pack. It's part of the packing foam, and I've just popped a little piece off. I've just cut a piece off with some scissors, and I'm going to mount the board with that foam covering the barometer, so that if there are any stray little winds about, which there absolutely will be because I'll be flying around in a quadcopter, then that's not going to affect the barometer. Next thing we need to think about then is orientation. Now the board itself can actually be mounted pretty much any way. There is an arrow which is pointing forwards. The challenge can be with this is if you install it like this in a 250 quad, then the USB cable is here at the back. A more sensible option could be to install it into the quad in this orientation where the ESC connections are presented here on the right, and we can get to the USB here on the other side just by plugging it in. Or similarly, we could mount it this way round. So we have the ESC connections here on the left, and this time we can still get to the USB cable. So if we want to change it, update the firmware, do bits and pieces, we can very easily just plop the cable into the side. I'm actually tempted to do it this way myself, so orientation is something you need to consider. Vibration. Now, vibration is a nightmare. If you have too much of it, then the board can read that vibration depending on the sampling rate as unintended movement, and it can cause some really weird and wacky stuff to happen. So we need to make sure that we are doing as much as we can to make sure the board is feeling the movement of the craft and not feeling the vibration. Now the way I'm doing this is I'm going to spend a lot of time making sure that my motors and props are balanced. I'm also created a little mount for the board that I'm going to use here. This is actually a piece of moo metal which is going to provide my magnetic shielding, and here we have double-sided foam, and this foam is the type that will actually help get rid of any vibration. So I'm going to stick this onto the quad, and then the flight controller is actually going to sit on top of these pins. And then what I've done is I've actually made a little perspex cover, looks like a little Space Invader, and that's going to go on the very top, and that should provide me access to my pins without allowing all bits of stray rubbish to catch on the board. So that's how I'm going to build mine, obviously with the foam under here. So now the last thing I need to think about then is the pin style. For me, I'm actually going to install the vertical pins. So I'm going to pop this style pins all the way around the board. Now I know where it's going to fit, how I'm going to mount it, where it's going to sit in the board. I know that this for me would make a lot of sense. So I'm just going to very quickly go and do the soldering. I'm going to install the pins on all of the connectors with the exception of the boot pins, just because I know that I'm not going to be using the boot pins, but we will be using the UARTs and the other connectors at the side as we go through the series and add extra bits. So let me just stop the video there. I'm going to go and solder all the pins on, and then when we come back we can talk about connecting up the battery and the speed controllers. So here we have the board. I've just stuck it in the middle of this frame. So here's the package that we were just looking at, connected in the middle of this ZMR 250 quad frame. I've set it up like this. So I'm just going to go through a couple of gotchas when you're building these frames for any quad, really, just to make sure that you don't get into trouble. That way you build the quad once and you can then fly and enjoy it rather than keep having to go back and change things. So I've done a couple of things on here. First of all, it's worthwhile pointing out that the craft that I have here, this is the front. So I've actually installed the board because I can easily get to the USB port because it's a little bit higher. I've actually installed it this way. If I put up in the top right hand corner the graphic of the motors, so this is motor 4, this is motor 2, that's motor 1, and that's motor 3. So these two motors are going to spin anti-clockwise. These two motors are going to spin clockwise. Now it just so happens the motors I'm using on this particular craft have two different rotating locking nuts at the top of the motors. Some of them are black and some of them are silver, and they go one way or the other. If you get a pack and you're building these motors are actually the MT2204 2300 kV motors. I'm going to pop 6-inch props on these, which is about as big as you can get on a frame like this. It should give me pretty great performance. But if you get these kind of motors and you find that you have two different coloured locking nuts, then just be aware of that, because the way it works is that you want the motors when they're spinning to always be tightening up the nuts rather than unscrewing them. The way to check that that's the case is if you grab, so say for example this is motor 3, so this should be spinning in this direction. If I have the screw slightly loose and I just hold it and then spin the motor in the direction it's supposed to go, there we are, it's actually tightened the top up. If it's working that way, you've got the motors the right way round. What I have done, I've connected ESCs to the motors. I've just had to guess, and I've got a 50-50 chance of these motors turning the right way round. We'll test them when we plug this into clean flight and make sure that's all working. If they are going the wrong way round, so for example motor 3 that we've just talked about is actually turning clockwise rather than anti-clockwise, we'll just swap any two of the three wires between the speed controller and the motor to take care of that. A couple of other things I'll point out. I have installed a spare JST power lead in here. It's not actually going to connect to anything right now. Very worthwhile doing this, because when you come to add extra things later on, additional lights, FPV gear, you have the battery voltage available, the 12 volts, because this is a 3S model I'm actually making. You have the battery voltage available that you can just plug everything into here. And I've built the frame in a way that the back is nice and free, so I can put all my FPV gear here at the back. Other couple of things that I've done, let me just zoom in and I'll show you a couple of other things. First thing you'll notice is I've popped a buzzer onto the craft. That's going to plug onto the buzzer pins here. Make sure you're observing polarity. The negatives at the back, positive at the front. So let me just pop that on. There we go. So now next time we power it up, it'll start shouting at us. The other side of the craft, what I've also done is I've also run a couple of little leads off the power distribution board, which is under this main flight deck, and again, that's going to provide battery voltage, but onto these VBAT pins here. Let me just move the ESC connectors out of the way. And these VBAT pins, again, be super careful with polarity. The negative is on this side, positive is on that side. So let me just install these two things. That means that later in the series we can enable VBAT, and we can have the battery voltage being read by the board, and also then potentially being sent back to the Taranis radio and other telemetry systems. And then finally what we need to do is plug in the motors themselves. Now the way the motors plug in is pretty straightforward. The outside pin is the negative, the inside pin is the signal. Now what I've done is, as I was building the craft, I made a note as I was building it of which motor was which, and on the corresponding servo lead, whoops, you'll notice that that's obviously motor 1, which is the back right motor. That is going to be motor 3, which is the back left motor. That one is motor 2. You get the idea. So I've actually written the numbers on. So to connect it up is actually really straightforward. So on the board itself, this is motor 1 on the right hand side. So I plug in the servo lead from motor 1 into output 1. Watching that polarity, making sure that the signal is towards the middle of the board, that the negative pin is the outside. That is 2. So we plug motor 2 into output 2. Motor 3 into output 3. And you guessed it, that should hopefully, if this works, that's motor 4, which it is. And again, I'm going to plug that in. Be super careful about polarity with this stuff. It's something that's all over the documentation, and I'm sure it's there for a reason. Okay, so there's our 4 motor wires connected, and what we're doing here is I'm actually using linear ESCs in these little speed controllers that I'm using here. So I've used these on a number of crafts, so I'm quite happy that I'm going to keep all the red wires connected, and these red wires are actually going to connect the SP3, but also then power the receiver for the radio as well. If I was using switched ESCs, then I would unplug the middle red wire of all but one of these connectors. If I was using opto ESCs, then what I'd have to do is, using a separate battery eliminator circuit, plug it into another one of these spare outputs to provide the plus 5 volts to run the board, but also to power and make sure that the opto ESC is powered on. There's actually a video here that you can go and learn all about ESCs and different types. If you're interested, you can go and watch that. So now we have the flight controller all plugged in. We have our 4 ESCs, we have our connection to the VBAT, and we have our buzzer. Now what I'm going to do is I'm going to install the top of the quad, and then we're going to plug it in and check it's all working. Last thing to do before you go any further is double check that the polarity is absolutely right on every single one of these connections. If you get it the wrong way around, you're going to blow the board up. So, netbook time. So here's the model on the desk ready to go. I've put the top on and I've also just popped a flight battery so that we can plug it in. We're going to need the flight battery because we're going to check that the motors are happy and that I've installed them the right way around and that also they're rotating the right way too. We're also going to calibrate the ESCs so that they are ready and working with the flight controller and the transmitter. Last couple of things then we'll do is we'll set up the modes so that we have a stabilized mode ready there available so we can fly with it on our first test hover, because we want all the help we can get and just see how the craft's behaving. And then finally we'll check how the arming's working, make sure we can arm the board and everything's happy. And the last thing we'll do is we'll actually fit the props onto the arms and then go in the garden and give it a quick go. You'll notice that there are no props on at this point. This is really important. We need to make sure that we have absolutely no props on here, because when we plug it in, we're not exactly sure what's going to happen. We may have an uncommanded start, something weird might happen. As we're playing in clean flight, something might kick off that we weren't expecting. We don't want props spinning on the bench and getting into trouble. I've had a couple of uncommanded starts in my early career with helicopters and I actually bear scars from that happening. So always make sure, safety first. First thing we're going to do then is we're going to connect up to the PC. So in the back of my board I have a USB cable plugged in. So let's jump onto the netbook and we'll plug it in. So here we are, we'll plug the board into the netbook. There we go, it's booting up. And here we can see it, fantastic. Always worthwhile recalibrating the accelerometer once you've fitted the board inside a craft, just to make sure that the mount is perfectly level. If it isn't perfectly level, then obviously you're going to get a bit of drift when you try and fly. So the thing we need to do then is jump into the motors tab. And here we can actually see how the motors are supposed to be laid out. This is the one we saw when we configured the board, and also now how we're actually going to set it up. So what we can do is we can actually tell CleanFlight that we want to take direct control of each of the speed controllers and send it pulses. So the way we can work here is actually by ticking this box in the bottom right hand corner. It does say we have to remove all propellers, and we have to tick that you've understood the risks. Propellers are removed and enable motor control. So what we're going to do here is I'm actually going to plug the flight battery into the model because the ESCs need power, and we should hear the ESCs beep when I plug this in. Okay, those guys are armed. So I'm going to click I understand all the risks. And if I power up the master, you shall see all the motors spin. Fantastic, that's promising, they're all working. And we can individually check each of the motors. So for example, the bottom left hand motor here is motor 1 on the screen. So if I increase the throttle for just motor 1, I should see it spin. This is also a great opportunity to make sure that the motor is spinning as it appears in the diagram. If it isn't and it's going the other way around, just unhook any two of the 3 wires that go from the ESC to the motor and just swap those 2 over. So let's just test that one. Perfect, that's going the right way. If I do motor 3, then that should be this back left one here. That should be rotating anti-clockwise. Let's test that. That looks fine too. Great, okay. So we now know that the motors are all working. The next thing we need to do then is actually calibrate the ESCs. So what I'm going to do is I'm actually going to unplug the battery here. And I'm going to increase the master. In fact, the maximum's 1850 on this one because that's what we've got it set to. That's perfect. So while it's set at that level, I'm going to plug the speed controllers in and you'll hear them go into ESC programming mode. There they are. And now I'm going to drop the master straight back down to low position. There we are. We now have the ESCs set as well. Fantastic. We are getting very close to being able to fly. Going to untick that box so that we are safer. Next thing we need to do then is go into modes. So here we are in the modes menu, and you can see here that if I flip my mode switch, you can see the little yellow tab moving for that mode channel. So in that position, I'm in angle mode. In horizon is the middle mode for me, and the top, it's horizon and baro. Now we're going to do a video later on that explains what all these modes do, but I'd always recommend, if you're going to try and fly, make sure that you're at least in angle or horizon mode. Those are the kind of the self levels. For the first flight, it's better to have the help. If you have no mode selected at all, then you're in rate mode, which can be exciting, and for the first flight I wouldn't recommend. Last thing we need to do then is make sure that we can arm the board. Now at the moment it isn't armed, but to arm it, what we need to do is to hold the throttle to the lowest right hand position. So what I'm going to do is just move the model to the side. So here's my Taranis radio. To arm the board, what we need to do is keep your throttle to the lowest position and hold it to the right hand side. There we go, now we're armed. And to disarm, you keep it to the bottom left hand side. That's working perfectly. You know when the SP3 is armed, hopefully you'll be able to see it here, when I arm the board you'll see the red light go solid, and when I disarm it, it goes out. So that's your arm indicator. Okay, now we are pretty much ready. So the last thing we're going to do then is we are going to balance the props and install them onto the motors. Let me do that and we'll come back and have a look. The props are now on. I've had to put a little bit of tape on a couple of them. One of them I had to shave a little off one side of the hub because it was slightly lopsided, a little bit of the flash from when they were made. So just to confirm that we have everything on the right way, couple of quick tips. Occasionally new builders get caught out. You want to make sure that any writing that's on the prop is facing upwards on all of them, and just double check that if we get our little diagram up in the top right hand corner again, if you actually move the props in the direction the motor's supposed to be spinning, that it looks like the leading edge of the prop is higher and the trailing edge is lower. That means it's going to be forcing, as it turns around, the air in the right direction. As you can see, the 6-inch props on this frame are as big as I dare. It gives me about 6, maybe 7 millimeters clearance on the frame at the front for where we hold the bits and pieces. But actually, you know, that's gonna work fine. Now we've done this, the last thing we need to do then is to get this out in the garden and give it a test flight. The only thing I've got to do is to plug my buzzer back in. The reason I took the buzzer off was because for the last segment, as you probably noticed, the audio was a bit interesting because I was using the bench and I was using a laptop on one side and the model on the other, and having the beeper going off at the same time would have just been even more tricky to edit. So let's go to the back garden. Give it a try. So arming the board, and I'm just going to have a very gentle first hover. I'm just testing the controls, making sure that nothing's reversed, doing some very slow pirouettes, just seeing how it responds. This is in angle mode, so this is essentially self-level that we're looking at here, and hopefully you can see and also hear from the video that the control of the craft and the way it's performing is actually really good. Don't forget, we haven't done any tuning or PID setups here, and it's actually using the default multi-wii PID loops, which are probably the oldest and most mature on the craft. There are other ones that we can try, and we can play with those later in the video series. But my first impressions are very, very good indeed. My first goes with the NAS A32 weren't as good as this, I'll be honest. They had little problems with oscillation. This board on this little 250 class quad is actually giving a really, really nice experience. As you can see, it's very, very smooth. I will be carrying on in the series, and we'll be looking at some of the other features that's available in the Seriously Pro F3 flight controller. We'll play with black box, GPS, LEDs, we'll have a look at modes, we'll go through everything that you, the subscribers, has asked for. So hopefully now, after watching the first and second video in the series, you should be about where I am now. So you have it flying and you're ready to explore the additional things that we can do with this board. Thank you for taking the time to watch that video. There are lots of other videos on the channel and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching. Please like, subscribe, and happy flying.